Okay, now here's some of the hard problems. So let's go through these slowly. We're at 22. Eric has $3,000 in his account today. So times 0, he has $3,000. He will deposit $5,000 at time 3. And at time 6, he wants to withdraw $10,000. And at time year 10, he wants to withdraw $15,000, but he's going to be making deposits every year. So he can do this. He wants to make deposits every year. So I have 10 total deposits. The interest rate is 10%. Present value, this is where it gets a little tricky. Present value and future value, if I had those, I could very easily tell you what the payment was. Alright, so how do I get the present value? Well, the present value is the $3,000 plus the $5,000 divided by 1.10 to the third. So basically, it's a 3. I'm taking this $5,000 and putting it back there. And that will give me, so I have to find my notes. That'll give me our present value of $6,756.57. So make that positive, because that's money we're putting in. So the 5,000, take the present value of the 5,000 like you did in one of the earlier problems in the test in chapter 2. Add it to the 3,000. That's the same as depositing $6,700 today. Same thing here. I need to move that $10,000 forward. So the value in year 10, the present value is the value today. The future value is the value in year 10, which is a 15,000. Let's make that minus, because we're withdrawing, minus a 10,000 times 1.01 to the fourth. To move that forward 4 years from 6 to 10, that would be 29,641 exactly, and that's going to be a negative. So I need to move this $10,000 from year 6 to year 10. I do that by multiplying. I need to move the $5,000 back 3 years. That's the answer. There's a chapter 3 problem almost identical. This one, number 23, it's a timing issue, is a big part of it. So for 3, I'm just going to put 3 for 300,000. I get $300,000 a year for 4 years with the first payment made today. And then the first payment made in year 4, and I get 6 of them, so that's 5, 6, 7, 8, 9. That's 800,000. So I have 2 annuities I need to add together. So N is equal to 4. Payment is equal to 300,000. Interest rate is 5%. Future value is equal to 0. Plug this in. Find the present value, which is the value at year minus 1. That's equal to 1,063,785.15. But I need the value today, because I want to know the value of the money machine today. So that's value year 0 is equal to the value of minus 1 times 1.05. So that's equal to this number right here. And then the next one, I want to take these 8. So now these are gone. Take these 8. So N is equal these 8. These $800,000 payments. There are 6 of them. Payment is 800,000. Interest rate still 5%. Future value is 0. The present value is the value at year 3. And that value at year 3 is 4,060,553 0.65, but I want the value today, which is the value at year 3, divided by 1.05 to the third, which is this number right here, C. When I add those two together, that's the correct answer, D. So all I'm doing for this one, I have two separate annuities. You should be able to do these annuities like at the very beginning of chapter 3. I'm just adding them together. The timing is the issue, how I treat that timing. All right, so let's clear this off and go to number 24. There's a problem exactly like this in chapter 3 of Caspian Sea Drinks. Somewhere in the mid-30s, as I recall. I'm not sure exactly which one. That's why you need to work the Caspian Sea Drink problems. And you got to draw these timelines. So the value in year 30, that's what we're looking for. It's going to deposit $11,000. Today he has $11,000. He's going to deposit $11,000 every other year to year 10. And then I'm going to put this, well, I'll go ahead and do this part first. We'll forget about the $5,000 for now. So N is equal to 1, 2, 3, 4, 5, 6. 6, the payments will equal to 11,000. The present value is 0. By the way, I could say the payments are 5 and the present value is 11,000. Either way, it's going to work out. Here's kind of a trick to the problem. Interest rate is not 6% because these are 2-year periods. So the interest rate is 1.06 times 1.06 minus 1. So the interest rate is 12.36. Plug this in. Gives me the future value, which is the value at year 10. And that value at year 10 is $90,082.21. But I need the value at year 30. So the value at year 30 is the value at year 10 times 1.06 to the 20th. So note what we're doing. If I have every other year payments here, I need to change the interest rate to be every other year interest rate to match the periods, which are every other year. Here, I'm back to just 20 years from year 10 to year 30, so I'll go back to that interest rate, 6%, and this comes out to be $288,905.85. Now that's positive money, because that's money I'm putting in. But now let's do it in red. The other part of the problem I have in year 1, year 3, year 5, year 7, year 9. I'm taking out 5,000. So N's equal to 5 because there are 5 of these payments. The payment is 5,000. The interest rate remains 12.36, just like we had there. The present value is equal to 0. This gives me a future value, which is really the value at year 9 because that's when the payments stop. The future value is $31,992.22. And then I need the value at year 30, which is the value at year 9, times 1.06 to the 21st. And that comes out to be $108,759.59. That's a negative number, that's a positive. Add those two together, and we get this. Alright, so go back to one slightly. These next two are going to be a lot easier. It's going to pay every 6 months for 20 years, so we have 40 total payments. So in this case, N is equal to 40, payment is equal to 500. The interest rate, this is where you have to pay attention. Interest rate is 8% per year. These things are being paid twice a year, so that's 8 divided by 2, which is 4. Future value is 0. Solve for the present value, and we got it. This one, 26, is like one of the earlier problems. Year 16. So the value at year 0 is the value at year 16, the 32,000. divide by the 1.12 to the 16th, which is right here.